Okay, in this presentation we are going to look at statistics with R presentation. This is an introduction to R for actuarial students. So this corresponds to the CS1B curriculum, which is statistics essentially, but this is the R component. And this comprises an introduction to R programming and fundamentals of statistical analysis. And this particular presentation corresponds to question 1 of a paper. So it's a short enough, straightforward enough question really. An employee at a cafe has been trained to set the coffee machines so that an espresso coffee portion results in 2.0 grams of coffee being placed in a cup. Knowing that variations are to be expected, the employee pours 8 portions and knows the amounts to be the following: 1.95, 1.80, 2.10, 1.82, 1.75, 2.01 and 1.83, and finally 1.90. So calculate a 95% confidence interval for the mean size of the espresso coffee portions. Comment on whether or not the mean portion of coffee is equal to 2.0 grams. This is the true proportion of all the coffees that are going to be portioned out. And then repeat exercises 1 and 2 for an 80% confidence interval. So the command we use, first off actually, we just sort of set up the data. We're going to call it amounts, okay? And those are the values there, 195 to 190. We concatenate them, which is to say we combine them into a single object, a single vector. Now this is a straightforward enough presentation, so just actually do some data inspection here. So some useful commands. Head. This prints out to the screen the first 6 items, okay? If you want to specify a different amount, you can just put in a second argument there, comma, and whatever number of items you want. The complement, the counterpart to that is tails, which prints out the last 6. Useful to know, try them out. So there are 8 items there, we can tell that by the length command, okay? And this is stored as an numeric object, a numeric vector, so class and amounts. You know, those are 2 useful ones to look at. Just practice those commands there for when you dealing with any sort of objects, just as sort of interest to sort of learn more about R and how things are stored in memory in the R environment. So anyway, for this one we're going to use t-test, and not that we're carrying out a t-test per se, it's that we are going to use this to generate a confidence interval. Now the confidence interval level is 0.95. Now we don't really need to specify that in this particular instance because it's the default setting. 0.95 is the default confidence level. It's just a sort of a convention of undergraduate statistics that just got carried on. So this is our confidence interval here, this part of it here. So it goes from 1.79598 to 1.99402. Okay. So from the output, that's our 95% confidence interval. So the employee sees that the value 2 is not in the interval, and therefore I hypothesis that the true proportion of weights, that the mean of that would be 2 grams, would be rejected at a 5% confidence level. Okay? So based on that, we reject the hypothesis that the true mean is 2. Okay? Now, just as a quick remark, this setting here does not pertain to our hypothesis that the true mean is 2. Unless we specify a mean here, that means that the true mean would be 0. Okay, that's how we would interpret the lack of an input there. So the default setting is 0, which makes no sense in this case. We'll leave that for another time. There's more to do that there, but we'll leave that for another time. We're only after confidence intervals in this particular instance. So what we can do there, just the next question is repeat the analysis for 80% confidence interval. So confidence interval there is 0.80. Okay, let's look at our confidence level confidence intervals there, 1.83 to 1.954. Okay, so there we go, 1.836 and 1.954, and again same conclusion. We at a 20% confidence interval, we would reject the null hypothesis that the true mean of the portion sizes is 2. Okay, you just notice that this actually is a little bit narrower than this one here. Okay, so it's more compact around the mean. Now that's the question done essentially. We'll just actually sort of as a quick remark, what happens if we do set at a confidence level of 0.99? Well, 2 is in that range of values, 1.748 to 2.04. So using a 1% significance level, we fail to reject the null hypothesis that the true mean is 2. That's just sort of an additional component to the question, just to sort of, challenge ourselves as much as possible. What is otherwise a very straightforward question. Okay, we'll leave it there.